Good afternoon, everyone, and thanks for joining us today to discuss the applications and implementation of 3D printing technology in the lab. Some of the key topics we'll cover is the different 3D printing technologies, specific applications of 3D printing in the lab setting, strategies, workflows, materials, and space requirements needed to successfully integrate 3D printing into a lab. If you have any questions, there'll also be time at the end for Q&A. Before we go over some of the different 3D printing technologies, I wanted to touch on some of the key applications that are most popular for lab managers in a research setting. So the first one here is micro and millifluidic research. So researchers at Harvard, for example, are using 3D printers to create millifluidic devices to measure the flow of liquid and test their hypotheses. We have prototyping and design for the lab. For example, MIT meteorology researchers are using 3D printed prototype parts to create virtual impactors to separate ice crystals and droplets for testing. And the third one there, research models for teaching. So for example, at Princeton Sung Lab, they are using 3D printing to explore neurons and using 3D printed models to provide a fuller understanding of their complex structure. So now we'll go into a 3D printing technology overview. So with these applications in mind, there are many different types of 3D printing technologies that are best suited for different applications. There are three main types that we'll discuss today: SDM, SLA, stands for stereolithography, and SLS for selective laser sintering. So we'll start with SDM, stands for fused deposition modeling. FDM printers have become really popular for hobbyists. Uses plastic filament and an extruder to create a 3D object layer by layer. The X, Y, and Z motor control the movements on 3 axes, and an extruder pushes out the plastic filament onto the build platform to create the layer of your print. Material called filament is pretty widely available and fairly inexpensive, and the most commonly used material is ABS and PLA plastic. Stereolithography, 3D printers use lasers that are guided by mirrors to selectively cure liquid material and turn it into a solid part, layer by layer. The result is an extremely precise model in high resolution. Since the laser is much more precise than an extruder, SLA technology is able to capture more detail and has a higher quality surface finish. Selective laser sintering printers use a laser as well to sinter plastic-based powder material into a solid structure. Powder is dispersed in a thin layer on the platform, and a laser scans a cross-section of the 3D model, which heats the powder to a melting point and fuses the particles together. So this is an example of the same part printed on each technology. The left was printed on an industrial FDM machine that costs $150,900. That's an industrial machine. And the middle one was printed on the Form 2 desktop 3D printer, which is $3,500. And the far right is printed on the Formlabs Fuse 1 benchtop SLS machine, which starts at $9,999. There's lots of material options, and we're going to go over the SLA material options quickly here to give you a sense for what you can do with the printer. So SLA materials have a variety, there's a variety of them. These are some of the options available with Formlabs. Our standard material is great for high resolution models, which is on the top left there. Our durable material allows you to print ball joints and simulates polypropylene, while our flexible material on the top right-hand side there is great for creating handles and grips, and our high-temperature material is perfect for injection molding and can withstand temperatures of up to 290 degrees Celsius. Our tough material on the bottom middle there simulates ABS plastic and is great for working prototypes. And the bottom right there is our biocompatible material, which is popular especially with dentists for applications like surgical guides. Now we're going to go over the workflow of 3D printing. If you're thinking about incorporating 3D printing into your research lab, these are the key workflow considerations. So you start off with 3D modeling or 3D scanning software. You take your 3D model or scan file and convert it into an STL or OBJ file so that 3D printing software can read it. Then you drag and drop this into 3D printing software that will convert this STL file into what's called G-code. And that G-code just tells your printer all the details of each layer of your print. Then you send your files from your 3D printing software to your printer and press print. Once your print is complete, you remove your parts from the build platform, and then you can start with post-processing your print. So to go over this in a little bit more detail, we'll start off with orienting and supporting your models with 3D printing software. And before you can send your files for printing, you'll want to get your model ready to print in 3D printing software called slicers. The software is mostly available for online. Preform is an example of Formlab's free 3D printing slicing software. So to prepare your print, you may need to create supports for your model. Supports are necessary to provide scaffolding for any area of your print that might hang over 45 degrees. Slicing software also allows you to specify the layer height, which dictates the resolution of your print. The smaller the layers, the longer it will take your print to print, but the higher resolution quality you'll get. You should also consider how to orient your parts to optimize for efficiency and print speed. Now we get to the fun part, the printing. So when you're printing, you can only print with one material at a time with the Form 2, and we recommend having a dedicated tank for each different material. And when you're not using that material, you can store the tank in a cool, dry place with the lid that it comes with, and you can actually stack these tanks as well. There isn't a large space requirement for desktop 3D printers. You just need a small space for the printer, and we recommend a dedicated area for post-processing, which we will discuss next. After your print is finished, you can remove the part from the build platform, and with SLA 3D printers, you'll have to soak your part in isopropyl alcohol for 15 to 20 minutes to dissolve any excess resin left on the part. This step is not required for FDM printers. After your print is done soaking in isopropyl alcohol, you can then remove the supports manually. Moving on to post-processing. So for parts printed in an engineering or biocompatible material, we do recommend allowing your parts to cure, additionally in a UV cure chamber. This allows the materials to reach their full material property potential. You can create your own UV chamber with a basic nail salon UV box, which is pictured there on the left-hand side. Or Formlabs also has an automated wash and cure solution that washes and cures your parts for you. After your part is cured, you can go ahead and sand off any support marks that are left and brush your part in mineral oil to get that nice smooth finish. Now we'll sort of talk about how universities are using 3D printing to add value to their labs. So for example, the Mix Lab at Montclair State University is taking full advantage of 3D printing technology. Their director, Jason, believes that giving students access to top technology is key to driving innovation in their lab. Their students use both FDM and SLA printing for prototyping 3D models of new products that they're designing, for testing out their designs, and for research purposes. Their lab is open to all departments within the university and gives everyone open access to the 3D printers and other equipment, which is great. The lab also runs a fabrication and innovation course, which challenges their students to work with outside companies to consult on their designs. Many of the students required a tool that would allow them to prototype something in high resolution. So they purchased 3 Form 2s, which they now use for prototyping and solving problems with design. Montclair State University also uses their printers to bring energy into their space. It's a popular place for a lot of students and faculty to hang out, and having the best technology tends to attract the brightest students and faculty to the space. So one of the most popular questions, I think, for people who are deciding to bring 3D printing into their lab is how to choose the right 3D printing technology. So we'll go over what's the right solution for the right applications. So deciding on what 3D printing technology is best for your lab is going to depend on the applications that you're using it for, which features are most important to you, and what kind of facility requirements you have. FDM printers are best used for low-cost prototyping and proof-of-concept models, while SLA 3D printers are better for high-resolution prototyping and custom models. SLS parts are best for short-run production and custom manufacturing. The strengths of desktop FDM 3D printers are that they're cheap to operate and they're great for low-fidelity prototyping. SLA 3D printers are perfect for more high-quality prototypes that will go under some wear and tear. Both FDM and SLA 3D printers require support material, while SLS 3D printers do not, as their parts are suspended in powder. FDM, SLA, and SLS systems do require post-processing. So consider these points before deciding which 3D printing technology is right for your needs. Now I'm going to pass it to Chris, who will talk about his experience with 3D printing in a lab and some of his lessons learned.
Hi, this is Chris Haynes. I'm the shop manager for the International Design Center at MIT. We have a variety of research groups, mostly engineering and architecture based, in our facility, as well as 4 to 6 undergrad classes being taught there. Sort of collaboratively, we really try and get the different schools together. So right now our classes are mostly about engineering and design and how you bring that together. A focus on sort of smaller consumer products for that mostly, with then some just general design classes as well in the design language. So at MIT, at the International Design Center, my 3 spaces, I have a large assembly space, hand tools. I have a sort of wood and metal shop, which is large stationary power tools. And then most relevant to this, I have a digital fabrication shop, which has soldering, it has laser cutters, and it has a variety of 3D printers. So the 3D printers that we have currently at the IDC are a pair of Form 2 printers. We may be adding a third one. Ultimaker 3, a Mark Forged Onyx, a Mark Forged Mark II, an Object 24, and a Dimension 1200, as well as some other smaller printers that we have built with students, sort of more to teach them about how 3D printers work. Let me talk a little bit about the various, how these printers fit into the space. So for the different, any printer really, you want to have an idea of what you're trying to get out of it. One printer isn't going to do everything that you want, or if it does, it's going to be a very, very expensive 6-figure printer, and probably also quite expensive to run. Some of the support contracts for printers can run, I think some of my printers have a $3,000 a year support contract on them, and you can be kind of locked into that. And that can be one of the nice things about the smaller, I guess, more friendly companies on 3D printing is that it's nice to be able to get parts without having an expensive contract on it and get material without having to go through that proprietary material. Formlabs does sell very good resin, and some of our labs actually also do use their own little blends, and it's nice to have that option. So you're going to want to consider that an operating cost of the printer. So with any printers, as the slide here is saying, I really encourage you to have somebody that's going to sort of take ownership of that. There is no 3D printer that I have found which isn't going to have some sort of issue at some point. It's getting closer and closer to plug and play. But especially I have 150 students, 20 researchers, postdocs, graduate students. Somewhere at some time, somebody's going to have an issue with the printer and it's going to break. And having somebody really in charge of your printers is going to make that a lot easier. rather than, oh, there was 30 students all using the printers and something happened at some point. We don't really know why it's broken. And this is really the case with SLA printers. Resin is a great material, but it is very, very, very messy. And I have talked to other labs at MIT where, especially when the Form 2 first came out, I said, oh man, you got the new Form 2, that's so great, how's it working? And they said, well, I had it in my office for 3 weeks, I was the only person using it, and it worked beautifully, and then I put it in a general circulation, and it's kind of coated in wet resin now. People weren't quite as nice to it as they could be. I mean, these are precision machines, and so you really want to treat them as such. So really have somebody that is your point person. Hopefully they become an expert in any kind of little quirks you might find, and that could also be how to set up models in the software. The printing is sort of the next to last step, with finishing being the last step. You can really make or break yourself much earlier on when you're designing your part for the printer. As Lauren said, different technologies use, the different technologies will give you different types of parts, and for example, with SLA, hollow cavities in your part can be a problem, and the same thing with powder printers, because you'll have wet resin will get trapped in there. That's a pretty easy problem to solve, but you want to be able to do that in software, and that's where having somebody who is an expert on it can really help with that. Another thing is just trying to make a printer do what it's not designed to do. So, for example, I really like my Mark Forge printers. However, if I need an airtight model, they can't do it. I have some small cases that are getting printed right now for medical equipment that will be used in the field in India, and they need some of them to be basically waterproof. And an FDM printer just isn't going to do that. So you have to, don't try and force it. Find the right tool for the job on that. That's one of the reasons I have all the printers, is that each of them does something very well. So again, pick the right tool for the job. Treat it like a high-precision instrument, and also then plan on redundancy. Sooner or later, something will break. For my first Form 2 printer, we just got our second one in. Like I said, we'll be probably getting a third one. I have had one issue with it, which was the Z-axis went out. And that was actually fixed within a week under warranty. So that was great. But at some point that's going to happen, and it's probably going to be when you have a big, huge deadline due. So if you do get a technology like 3D printing into your lab in your space, and you find they're using it all the time, try and plan on a little bit of redundancy on that. So here's just some quick pictures of different parts. This is really why you would choose an SLA printer like the Form 2, is that the level of accuracy you simply can't get with FDM machines. Just can't get it. Now, there are some things, some engineering applications where an FDM machine is absolutely the right choice. There's also build volume questions. So, be realistic about the size of parts that you want to make. And it's very easy to think, oh, I need a 2 foot by 2 foot printer. I need to, do an absolutely huge print volume. But, be realistic about that. And if you do need a really large print volume, then, look at a printer for that. Why choose the Form 2? The price-performance ratio. We are looking at some fancier machines right now, but they're in the six-figure range. And what they're going to really potentially do is make things a little bit easier for some of the labs. But whether that's worth $150,000 is something you need to sort of consider. And again, I found the Form to be fairly reliable. As a shop manager, that is something that I really value. If I had to choose one printer out of all my printers, it would probably be the Dimension, just because the thing is such a workhorse. It's just a straight ABS printer. Probably gives the worst quality prints of all the printers in my shop, but I can leave the thing running for 3 days and come back, and I'll probably have prints. But there's certain parts that I just can't do on that. So the other nice thing about the Form 2 is that, again, going along with the reliability, is that it's not quite plug and play, but it's pretty close to it. And with our lab and our space, we're not necessarily trying to teach people how to build a 3D printer. And that's sort of a decision in an educational environment you need to make, is that do we care about the final product, or do we care about teaching the process of what a 3D printer is and how do you troubleshoot a 3D printer? And I've made kits with students before that have been absolutely about making a 3D printer and not about what the final result looks like. But for a general shop environment, it's great to have a system that all works together very well. And then finally, designed by MIT grads, so that definitely counts for something around here. So I guess at this point, let's go to some questions here.
Great.
So, all right, let's see. Any best practices, suggestions for charging users for printing, or how to create that line item in a budget? So there is some third-party software which you can do some research on, which will set up print queuing for you. I do not use that. What I do is I have a Google doc that people fill out and they submit, and it says what they're looking to print, what the print volume is, when they need it, and then they upload an STL to a Google Drive, and that creates a spreadsheet for me, which I can then charge them. MIT, we have a tech cache system which students can use, and how you want to charge people. You can just say, hey, you're using 150 milliliters of resin. The resin is 20 cents a milliliter, so I'm going to charge for that. You're going to want to factor in build plates and resin tanks. Formlabs recommends changing out the build tank every 2 to 3 liters of resin, so add that onto the price. And I will tell you that it depends. I don't know what your budgets are like. I found that sometimes it's not actually worth my time to charge somebody $3 for a print. By the time I actually bill them for that, it just isn't. It's not really worth my time. Now, if people then say, "Hey, we're all going to print a bunch of Pikachus," and if you use hundreds of dollars of material, then you're going to have to start charging. I can talk more about that later. I would say just try and keep a good record of it. I find that online is, like I said, the Google Docs is our solution to that.
Jason, did you want to take over the questions?
Sure, I can take over the questions for you. So one of the questions I have here is, how long does it take to learn how to use the Form 2?
Yeah, that's a great question. So the Form 2 itself you can probably figure that out in a couple of hours, is what I would say. It's very plug and play, and that actually goes for a lot of modern printers now, I find. Where I have seen from an educational standpoint, again, the real learning curve come in is in the software to actually make the models. So Freeform does a pretty good job of orienting the supports. If you just sort of click on the automatic button, I tend to like to tweak it a little bit, but unless it's a very challenging print, you can load an STL into Freeform and probably have a print ready to go in 5 minutes or even less time than that. Setting up the printer, again, is very easy. The only real tough problem I have had is MIT is very, they don't like Internet of Things devices on their networks. So I have to actually put in for static IP addresses for anything I'm going to have connected online, which is nice with the Formlabs printer in that you can still just plug a USB cable into your computer, upload the file, hit print, and then you can unplug your computer and go about your day. I would say that the other tricky thing can be figuring out how to remove the supports so that you have as little cleanup as possible. And that's going to really depend on what you're trying to print. If you have, say, a lot of people print electronic device cases at MIT where I am. So a lot of the times the insides of those cases, they don't really care so much about the what it looks like. So if you orientate the part so that the support structure is on that interior part, you clip off all little supports, and if there's little nubs left, it doesn't really matter because you're never going to see it. Just little tips and tricks like that you figure out. but yeah, it's a very easy printer to get up and running. I've had more issues with my Ultimaker 3 than I have with my Formlabs printers. So.
Formlabs also has a support page with a lot of in-depth articles on what you need to know to be successful with the Form 2, and we have a pro service plan, which includes an introductory one-on-one tutorial with one of our pro service engineers, and after an hour with them, most users have a successful first print.
Excellent, thank you. Now, Chris, do you or does IDC generally conduct user training before you accept jobs?
It's a great question. So I actually run our form printers. I run it more as a print service. Some of my other printers I let people just print on. The issue, like I sort of alluded to in my earlier presentation, is that undergrad students and sometimes researchers aren't as careful as they could be around wet resin, and the printers can get pretty gunked up if you're not paying attention to them. But what I do is any student that's interested or any researcher that's interested, I'm more than happy to show them the process, show them the preform software, which anybody can download. And so at that point, really, if they wanted to get the file all set up to print how they wanted in preform, they could then just send me the setup preform file, and I could run the print job on it.
Excellent, thank you. Now, I've had a number of questions asking about air filtration requirements.
Sure.
Are there any specific requirements for the resin when using SLA?
There are not. No, there are not. Now, keep that in mind. The room that I have my printers in also have a pair of 2 foot by 3 foot 120 watt laser cutters in there, which have their own roof mounted ventilation system. But you can still get some smell from the laser cutters, and so that tends to overwhelm any other smells that might be in the room. I have found that in my office, when I've had a form printer in there, that is probably 8 feet by 10 feet, maybe a little bit larger. I do find that I can smell a little bit of the resin smell. Now, I also have the finishing bath in there as well, which does have the isopropyl alcohol. And they don't smell like, cooking like PLA printers can smell nice. But I'm not, well, let's ask the Formlabs people. I'm not aware of any toxicity results for breathing in the resin.
Yeah, it's not necessary to have ventilation for the printers. For the isopropyl alcohol baths, the ones that come with the printer, it has a lid on it, so we definitely recommend closing that lid as it's flammable, mostly, but also because of the smell. We have wash and cure as well, which sort of solve that problem for you because they are contained within themselves. So that sort of takes away the risk of any isopropyl alcohol fumes getting out there.
And that's actually, the wash and cures, those I don't believe have actually been officially released yet. And I'm not going to lie, so I have a 400 watt, very high power UV curer. Will destroy a print if left in there for too long, I found out. And when I first saw the wash and cure systems, I was a little bit skeptical, I'm not going to lie to you. But I'm sort of starting to come around to the idea of just an automated system. And again, this is, as a shop manager who has a lot of equipment that I have to maintain and a lot of people using it, anything that I can do to expedite a process and make it as easy for my users to understand as possible is a good thing. And so I'm actually considering the wash and cure system. And certain people will obviously say, hey, for $30 I can get a UV cure and I don't need any kind of $1,000 fancy system, and totally hear you on that. Or you can also put your parts in the window. The sun is a great source of UV. But yeah, I haven't had a big issue with the air quality, and I've also had EHS's environmental health and safety is right above me in my building. So I haven't had any complaints from them yet either. So.
Perfect, thank you. Now, our next question asks, how strong are the printed parts, and are there materials that reach stainless steel strength? and are liquid tight?
Stainless steel strength, I think you might be disappointed if you go for resin on that. I think you need to look at either a mark forged metal or one of the new desktop metal machines, which, for $125,000, those two can be yours. I've actually used mostly the clear resin. That tends to be what people like. I'm starting to use the tough resin more. I've just got some of that and I'm experimenting with it. For more structural parts, what I've been using is FDM-based machines with nylon, especially the mark forged machines. I know this is in the Form offices here, but Form Labs offices, but for strong parts, nylon is pretty good, and especially if you add in either the Kevlar or the carbon fiber reinforcement with a Mark II printer, that works pretty well. Our BattleBox guys really like that. However, I would not guarantee it being airtight. And I've also found with the Mark Forged printers that certain geometries, some geometries print beautifully, other ones do not print at all. So I don't know. The tough resin is a little bit, it's stronger, but it's still a little bit flexible. And it's actually, Cody, this is a question I have for you: is the tough resin tappable? Can you tap a threaded hole in it?
You can. We actually have a guide for that on our website.
Great.
That provides an overview of exactly what type of threads we recommend for use with our tough resin, and exactly how to go about that process. But our tough is tappable. Yes.
Okay, great. The regular resin is definitely not tappable. I found that out the hard way. It kind of crumbles. So yeah.
Our tough resin simulates ABS plastic,
Yeah.
so that'll be our toughest one. Definitely doesn't get to the point of steel, but for things that are really strong, definitely recommend maybe the SLS option with nylon.
Right. Yep. So they have, and I haven't seen the new that new printer. Now, another thing to consider. So a couple of little pictures that you saw were molds actually for wax models, and they are the ones all the way to the left-hand side. They don't look like much, but what those are is one of our labs is casting wax pieces in those, and they're these little feet for these lanterns. So then they do lost wax casting off of those wax pieces they've cast. And so I actually just printed up another 4 of those today for them because they need to mass produce those. So they're casting in either aluminum or bronze for that. But you can certainly look into casting facilities which will do lost wax casting in other materials. I believe that BMW actually, some of their engine parts, they do lost wax casting for, and I'm not sure what they're using for material on that. And so that actually brings up another good point, which is that whatever you print off of your printer doesn't have to be the final part. So, for example, another fellow actually was getting married last summer, and he wanted to do a cast bell for his wedding. As part of the wedding ceremony, they had a big fire and they did iron casting. And he printed the positive for it on our form printer and did this little bell, which they then cast and rang. So the form does not print metal, but you can use it to then cast metal with. So think about multi-step processes or process AI.
Excellent, thank you. Now our next question asks,
Sure.
Is having a 3D printer in the lab good only for prototypes, and is it really cost effective if you have to scale up?
Well, scale up to what, I mean, for hundreds of parts, for thousands of parts, for 10 parts. It depends on what sort of, how large you're looking to scale up. Ultimately, if I'm, looking to do thousands of parts, I'd be looking at injection molding. We have people on campus that do injection molding. There are services now that will make aluminum parts to do injection molding. What a 3D printer really is nice for is making sure that what you're going to spend tens of thousands of dollars on for molds is actually what you want and is what your client wants. I've also found that for doing jigs, 3D printing can be very useful. The FSAE team, which is the electric race car team at MIT, for some of their welding, they were doing jigs on the printers to then set up to make their frames, which, yeah, I don't know, for scaling up, for large scale stuff, 3D printing is it's more of a prototyping technology, I guess, is what I would say, unless you're doing really small stuff. Yeah, but really getting whatever you're trying to make correct and right is pretty valuable, you know.
Chris is absolutely right. I think for small batch manufacturing, 3D printing injection molds is certainly viable, and for larger production requirements, I think our SLS machine would also be an option depending on what material requirements you need. But for the thousands and hundreds of thousands, you're probably looking at injection molding as the best option.
Excellent, thank you. Now our next question asks, how often do you usually change build tanks?
Well, I've been finding that I can get 3 liters of resin pretty easily off of it. And I actually know a professor at Mass Art who has not a Form 2, but a Form 1 Plus. And he said that he had put, I want to say, like 10 liters of resin through his without changing the build platform. That seemed impressive to me. But yeah, he wasn't having to change them much at all. And this isn't really come down to your budgets. So where I'm operating, I used to try and make every penny count and really try and reuse anything, even if it was, expired. I've had some resin that from 2 years ago, which I've been trying to use on the form printer, and I got to work, but it took a little bit of doing. But you really need to start thinking about what your time is worth, and that's a question I can't answer for you. But I think 3 liters of resin is pretty reasonable, unless you're doing the same part. Just maybe you were doing sort of small production runs, and you're printing in exactly the same place in the tank. So Form Labs will tell you to move the parts around, try to use different parts of the tank, and I absolutely agree with that. And you definitely don't want to gouge the bottom of the tank. And again, that's sort of just being careful. So yeah, I think the 2 to 3 liters is probably conservative. You could probably get up to well, I don't want to make any promises here, but I could see you getting to 4 or 5 liters of resin if you're careful with it. Cody, maybe you have more insight on that.
Well, sure. I'll mention a few things, Chris. Thank you. The first is absolutely rotating your parts as to where they sit on the tank and build platform is a great way to extend the life. We actually have a heat map feature, so you can track where prints have been placed on your tank and your build platform, and make sure you're putting those into new locations. And we actually also recently released a long-term use tank, which is going to be far away a much longer-term solution. Excuse me, for printing, and so that's going to be well in excess of the let's say 3 to 6 resin cartridges that Chris mentioned. So that's a great option as well if you're looking to get the most out of your tank.
Yeah, I mean, if you're trying to save money, again, you can use third-party resins, and that's sort of one of the things where I know people do it. One of our labs has a proprietary sort of flexible mix that they like to use. So you can potentially save some money on that. I happen to like sort of the plug-and-play nature of sort of just plunking a cartridge into the back of it. But again, that's sort of where I'm operating budget-wise, and that space and time are sort of more valuable to me a lot of the time. So.
Excellent, thank you. Now, could you speak a little more as to how much maintenance is required with the Form 2?
Yeah, definitely. So when I came in to our lab, we'd had the form for about a year, and it worked great for basically another year. And then the Z-axis died on it, and so I had to send it in for that. So besides that maintenance, I haven't had to do any maintenance for it. The issues that I'll go through all the issues I've had with it. So I found one, and again, I inherited a bunch of old resin and tanks and build platforms as well. So sometimes with the older resin, if it's been sitting around for too long and you don't shake enough, that can cause print issues, which can be frustrating because you're like, why isn't this thing getting chunks of resin in the bottom of it? I don't understand. I found that using fresh, relatively new resin, as in not 2 years old, making sure to agitate the tanks really worked for that. And I had one build platform actually was a little bit off level, and so that was causing some failures. And again, I don't know what happened to that build platform, but that's a $30 part, I think. And then there was the Z-axis, and there's a little slitter which slices the bottom of the resin tanks, and that seems to have dulled a little bit on our printer. So my fix to that is I take a razor blade when I have a fresh resin tank, and there's a little rubber nipple, and there's a little line, you slice that with the blade, and you're good to go. And that's probably something that the Form Labs could fix if I cared enough about it. I will say, though, that unlike some of the FDM printers, I can basically tear apart an FDM printer if I need to and sort of rebuild it. You're probably not going to do that with the Form printer. So do keep that in mind. If you're somebody that likes to tinker with stuff, if you like to be able to sort of see all the working gears and everything, the Form printer is a little more black box in that respect, I would say. But I haven't had much in the way of issues with it, except for that one Z-axis one. So, and believe me, reliability is that's pretty high on my list of what I look for in a printer. I know there are some other SLA printers that are sort of in the Form Labs price range. Some of them, I think, even claim higher resolutions. I haven't read fantastic reviews, but they're sort of more of a, you provide your own DLP projector, you sort of build the whole thing. So, and I don't work for Form Labs, so that's certainly, certainly an option. For me, I like the more plug and play nature. I just don't have time to play around with a bunch of different printers, even if I'd like to. Yeah, so hopefully that answered. I haven't really had enough issues that, there's just the Z-axis.
Perfect, thank you. Now, where do you see the biggest growth in the next few years with research in 3D printing?
Well, what people are really, next big, at least at MIT, the next big push is probably the metal printing at an affordable price point. There's a couple of different companies that have come out of MIT that are pushing the, sort of low six figures for metal printing. So I'd say that has the most buzz. In terms of with research, I think it's just really the ability to get usable parts within 24 hours is pretty amazing if you think about it, in complex parts. And so what people choose to do with that, it's really up to them. Whether it's a new electronic device, whether it's, there's a research lab that I work with that's doing sort of handheld small medical devices for the third world that, talk with cell phones, and so we're printing parts for the sensors to hold, monitoring bands. And it's, it's just super easy and super quick to do. From what I've seen, the printers keep on getting more and more reliable, and we're getting closer, and we are getting, actual mechanical parts. It's not just a looks like part, but it's a looks like and works like and is. And maybe, it's not a great way to make 1,000 of them, but, to make 20 of them to test out, it works great. Part of that is that a lot of the patents on powder printing have expired. And so we're starting to see a lot of research go into that, which is great. Sort of the more the merrier from a user standpoint. I want to see 20 companies all making fantastic 3D printers. So the other thing that I'm looking at for my lab for 3D printing technology is there's a couple of companies that are working on printing multi-layer PCB boards. And that's been, electronic components are a huge part of what really all the groups that work in my space do, whether that's engineers, whether that's architects, whether that's, anybody, whether that's medical people. And so there's a couple of interesting 3D printing PCB board companies which are starting up. So I'm excited to see what they come up with, because I have some small CNC mills for milling out PCBs, but even doing a two-sided PCB board is a little bit tough with that. There's some sort of registration issues. So yeah, 3D printing a 16-layer PCB board, that sounds great to me.
Mm-hmm. I think from a medical research perspective as well, we're seeing a lot of people printing custom models of their patients and using it to study before their surgery, or to study to have a better understanding of exactly what's going on, or for educational purposes as well, to teach their students exactly, for example, a brain aneurysm, what that looks like. And because you can tailor that and scan the model of whatever you'd like to print, it's all custom.
And custom prosthetics as well.
Yeah.
That's another great use of it. So anything where there's a one size doesn't quite fit all. Yep.
Excellent, thank you. Well, I'd like to thank you all for the discussion today. And this brings us to the end of today's webinar.